right. So let me start with a fact or a metric that really fascinates me in my line of work, right? So, which is the number of industrial robots installed per 10,000 employees by country, right? So this is as the name indicates, it's a how many robots are there per every 10,000 employees, right? So this is a list that gets published every couple of years. This is from, I believe, 2020, published in 2020. So as you can see, even South, this is a selective list. I believe Singapore is higher than South Korea in terms of this, but they're up close, right? So they're probably around 1,000. They must be around 1,000 in 2022, if I were to guess. So even the best of the best countries, if you look at that number is very relatively smaller compared to the as a ratio if we take in terms of employees, right? If we take a mean, probably it's around 2 to 3%, right? So even the best is probably around 7, 8, or 10%, right? So, but why is this important? So it is because one question that I'm always fascinated with is what if the ratio increases, right? So what if the number of industrial robots that are deployed, installed by country, if that and the gap between the employees and the robots reduces, right? So does it mean that we will have an autonomous factory, right? Just like an autonomous car, right? So can a factory run on its own? I'm hearing some echo. If others can mute, please. All right. So what I was saying was, sorry. All right, I'm still hearing some echo. I don't know if it is just me. Okay, all right, let me continue. Sorry for that technical glitch. Right. So what I was saying was that will we get an autonomous factory, right? So can a factory ever run on its own, just like an autonomous car? And so this is a question that probably few people are already asking. Maybe it's a fascinating question and exploration, but but I believe the right question to ask, while that question has its own merit, but the right question to ask is, if we aim for it, right? If we aim towards building an autonomous factory, can we get some benefits today while realizing an autonomous factory might take 5 years or 10 years, many years? Can we get some benefits today? So just like while autonomous cars might take many years to uh, while it might take many years to be realized, we are seeing the benefits in the auto industry, right? So in terms of advanced, assistive driving, advanced, the self-parking, lane assistant, all these things, those are the benefits that we are seeing today. While autonomous cars are still, some say might or might not be possible, the important thing is that while we are aiming to build that, we are still getting some benefits. As a consumer, we are still getting some benefits, right? This is a question that is more interesting to us and to me in my line of work. And then what I'll try to explain is some of the areas where how we can build some of these building blocks today that eventually will, with the help of AI, and if we build a lot of them, hopefully, right? So irrespective of whether we'll get an autonomous factory or not, these are the things that are certainly going to help us today. So, and just a little bit about our company Hindalco. Hindalco is part of Aditya Birla Group. It's a group based out of India. Hindalco specifically is a $25 billion company spread global. spread across 3 or 4 continents. We have factories in Germany, North America, South America, and Asia, of course. And no, just moving on in the interest of time, this is some of the presence of Hindalco. But what is interesting is if you look at Hindalco value chain, right? So we essentially are a metals and a mining company. We make aluminum and copper. We are a B2B2C company, right? So which means that we produce something that our end customers convert into final products like your beverage cans, or our aluminum is used in aircrafts or automotive, or applications are very wide. Uh, so what's interesting, if you look at our value chain, it's extremely complex. We have all the way from on the left hand side, this is our aluminum value chain. We have captive mining, which is coal and bauxite, which goes to aluminum refinery, and then we have a smelting process, and then after that there is a downstream process where you convert that primary metal into something more usable. And similarly on the value side, right? So now if you look at such an extremely complex value chain, how do you identify these building blocks that you want to build, so that will help, that will give you value today, not only a few years from now. So right, so you could take any of these areas, and such a extremely complex value chain, right? So first understand the business challenges, right? So for example, our business today faces, so since this is a highly interdependent world, so we are facing raw material shortages. There's a coal shortage globally, and there are supply chain disruptions, and because of various factors, macro and global scenarios, right? So the commodity prices are very erratic, right? So so over the last 1 to 2 years, right? So all these are real disruptions to businesses, right? So if there is a coal shortage, we might potentially have to shut down a factory, or if there's supply chain disruptions, or if you're not able to send to our customers on time, or because we are first and foremost a commodity company, and if the commodity price is highly unpredictable, that means that our profitability goes for a toss. So some of these business challenges, and of course the same related to quality and other the product quality and everything related to manufacturing is always there. Now, how do you take some of these business challenges and then see how AI can help? So what so very simple thing is, take any process, right? So the ideal way to break it down, right? So it's a series of steps, which is the ideal way to break it down is identify a business challenge, identify the process, convert that process into a series of steps, right? So you have a business objective. Let's say your product quality is continuously degrading. So maybe that is your business challenge and business objective, right? So that is your L0. The slide is intentionally blurred because there's an actual slide of ours. So that could be your top level business objective, and then you drill down and then further levels until you reach a point where you can convert each block into something where technology can help, right? What do I mean is, maybe at level 0, you have so maybe at level 0, you have a high level business problem, and then you bring it down to level 2, level 1, level 3, and probably at level 4 or level 5, you'll be able to break it down into smaller steps where you'll be able to leverage technology to help solve that particular step. In this case, right, so the gray at the lastmost at the level 4, so red indicates that solving that requires beyond data. But everything that is gray is a data problem. We could build a model to solve that problem. So first, identify what is a data problem, where AI can help and where AI cannot help, and these extremely simpler, very finely, narrowly defined problem statements. So once you have that problem statement, right? So probably this is at a level 0, you started with quality, but at here, by the time you come to level 4, you would have come up with building a prediction model for something. So that kind of a problem statement. So once you have that, so once you convert a process into a step, so how do you automate a step? So essentially, it's again, right? So this you have sensors, get real-time data from the sensors. So using the sensors and the real-time data. Once you have the real-time data from the sensors, build a model that will accurately be able to predict the outcome of that, right? So the prediction could be a few minutes out or a few days out based on the complexity of the process. But it's important to get the prediction right? So your prediction has to be as close to your outcome as possible, because this is the fundamental step that based on which, right? So you go to step 3, which is, you reverse engineer your prediction model and build a recommendation system, the so-called prescriptive model out of that, right? So you have prediction model and then build a recommendation engine to say that if you do these 2 or 3 things, you will be able to avoid that unwanted outcome. And so the build a recommendation model that will give you this prescriptions. And then someone has to act on that recommendations and close the loop, right? So while 1, 2, and 3 is still possible, I believe automating this 4 and closing the loop, right? And then making the machine-to-machine communication happen is really difficult, right? So if you're able to do that, I believe that itself could be autonomy. But anyway, I think 3 to 4 is easy, but 4 to 1, right? Closing this loop might be a little difficult. But anyway, it doesn't matter. Even if you're able to do 1, 2, and 3, even if you're able to do 1 and 2 today, that itself is extremely useful. This is what I mean by building these blocks today in the with the ultimate goal of something else, but that is still benefiting today. So while if this sounds like if let me just bring it home with a real example that we had developed, right? So now, so I'll play the video first, and then probably there's no volume. So let me just pause the video and explain. So what you are seeing is, this is a video feed from one of our factories. As I said, this is an aluminum ingot. This is called an ingot. So the process is quite simple, right? So you see the ingot and you see the arrow pointing in one direction. The right way to process this ingot is that the arrow has to be pointed in this direction. It is pointing to my right. If the ingot is processed, if the arrow is pointing to the left-hand side, it is going to have a catastrophic impact downstream, because this is a very upstream process. It is going to create a lot of, we might have to, recycle this ingot. That becomes very expensive, and as I said, it's a catastrophic event, right? Now, how do you ensure that this ingot is processed always on the right side? Of course, we've looked at multiple technologies, and historically, when we looked at it, a few incidents happen every year, and we have a large number of factories. Across factories, these incidents quickly pile up. So we looked at multiple solutions, conventional solutions, automation, looked at sensors and everything. But finally, what we have decided to do is that rather than doing any CapEx related investment, rather than installing more sensors, we have leveraged the existing CCTV cameras that are already on the shop floor, take a video feed from that, and we have built a computer vision model that alerts in real time if this ingot is being processed on the right side or not, right? So let me just play the video now. It comes, it is supposed to, it'll take that and then it'll process, right? So this is just a demo video that I've taken, right? So ideally they don't do it. So as you can see, right, so the moment they turned, the moment the ingot is on the left-hand side, the alarm the alert came out. So and what we have done is we have built this model. In a first step, we have installed a PA system on the shop floor, so that every time an ingot is processed on the wrong side, the alert goes out very loudly in that particular area on the shop floor, right? So everyone becomes alert and then stopped it. We have monitored it for a few months to got feedback and then improved the model. And once the shop floor and everyone gain confidence in the model, as a second step, we have closed the loop. Rather than sending an alert through a speaker or something on the shop floor or an SMS alert, we have closed the loop by sending the signal back to the control system. So now the control system waits for a 0 or 1 from the system. It proceeds only if it receives a 1. If it receives a go ahead from the computer vision model. If it doesn't, it will just wait there. The process itself won't start, right? This is what I mean by narrow down your problem, to simple things and then figure out how AI can help. Similarly, right? So another example that we had, that we had done is this is called as a soaking pit without getting into a lot of details. On the left-hand side, what you see, these are the same aluminum ingots. What it is it is just heating these ingots, so that they reach a temperature of about 500 degrees, right? So, and typically these are all images from public, by the way, from public web. So these they reach a temperature of 500 degrees or so. So what happens is, right, so while on the left hand side is how it looks, on the right hand side you get some schematic view of the thing. So if there are, let's say you have 8 ingots or 10 ingots in a soaking pit, they're usually blowers, and you don't typically get the actual metal temperature for all 8. You usually get either a 2 or a 3, but getting the metal temperature of every ingot is extremely important. You don't do it because it's become you don't do it for everything with a traditional thermocouple, because it is extremely it's expensive, it's time consuming process, and for various reasons, right? End of the day you have to show an ROI also. So what we had done is that we had taken the historical data of these thermocouples of these samples, and then we have built a prediction model that accurately predicts the temperature of all 8 ingots with to an accuracy of plus or minus 5 degrees. Plus or minus 5, or it might not sound, it sounds like, it doesn't, it might not sound like a big deal at, but at 500 degrees, right? So in order to get plus or minus 5 degrees is extremely challenging problem. That is the prediction side of it. So once we have the prediction side of it, again, right? So based on the temperature, right? So based on the actual temperature, you can feed it back to the control systems, and then again say what action needs to be taken, right? So rather than alerting it again, so control it, build a recommendation. I'll come to that. Loop it back, close the loop to the control system so that your process will become more efficient. Right. So what I all right. So what I have, right? So the way I could summarize, right? So is so if
Mr.
you are able
Gali,
to do, if you're able
just
to do
to
this
keep,
so far, you
sorry
would
for
have built
interrupt.
what we call.
Just to keep in mind that you have 2 minutes left for your presentation.
Thank you. So you will build what we call as a process digital twin, right? So which is, you build a prediction system first, prediction model first, to predict an event, and then that has to reach a very good level of accuracy. Once you have that done, build a recommendation engine that will prescribe something. So if you have a prediction engine, if you have a recommendation engine, right, so then you will have a very good shape of a process digital twin. So extend, so this is from a process perspective, but this is just still at a, still at a business level, maybe a little bit high level, where things get really difficult, right? When rubber hits the road, which is when you try to build the model. So you have a lot of data that is coming from your data sources, IoT data, customer data, raw material data, and you have a lot of techniques at hand, right? So all publicly available in all, thanks to open source libraries, all these techniques are available. Using this data and for this, using these techniques and keeping the business problem in mind, you develop few approaches, right? So for example, do I need a, if it is a regression, simply as simple as do I need a regression based model, or do I have to go with a classification model, right? So, and you develop with, you come up with various approaches, but where, the decision making, where it's really complex, is which model to choose. Because in the real world, right, so probably you would need models that are highly explainable, highly accurate, and they just work continuously without failing for multiple months, on and on. But such a model doesn't exist. What you'll end up having is something scattered all over the place. So speaking with business and speaking with multiple stakeholders, you have to compromise, or you have to balance between accuracy versus explainability versus time dependency of the model, and of course amongst other criteria. Right. So, and even if you've solved all of that, right? So even, let's say, if you've managed to finalize an approach, and right, so the real challenge, or if the fun part was building the model and maybe whatever it is, the probably the boring part is maintaining the model, right? So the so-called deployment drift, because your process changes at a factory, your raw material changes, people change, data quality change. So your data, as you see, right? So it will definitely change over a period of time. So how do you make decisions around, how often to retrain the model? Can the retraining the model piece, can it be automated, right? So this is where things get at the so-called MLOps, right? So this is extremely important, but often overlooked. Even if you're able to do all of that for one process, this is just remember that you have done so far only one simple process, or manufacturing. You can do the same thing from a logistics perspective as well, right? So same, identify your top level problem, drill it down until you build so many models that will be able to help you. I'm not going in detail in the interest of time, but over a period of time, what will happen is you will end up having thousands of models that are solving very simple problems. In isolation, they might look very simple, but you will end up having like thousands of models that are optimizing and that are delivering, that are making your products cheaper, better, faster. So if you're able to do this, and if you're able to expand this to other areas as well, right? So this is where, there is usually people, when they think of digital twin, people might think that it is only for your factory. But digital twins could be built for every function and area in your business, right? So there could be a supply chain digital twin, there could be a process digital twin, there could be a product digital twin, asset digital twin. If you're able to take a methodical approach and build these building blocks, and if you're able to model everything, right? So this is probably the ideal state, not as easy as I'm explaining. I'm sure most of your practitioners, you would understand, right? So, and of course, the goal is to reach here. Of course, that means that we have a long way to go, and I believe I have run out of time also. And thank you for your attention.